Hey guys, and welcome to section 2.8 on stoichiometry. Alright, so I hope you've had a look at Sal Khan's video, and I hope that that's helped. What we'll be doing here is we'll be looking at just one other way of thinking about stoichiometry, and then after that, we'll be going through some example questions together so that you can get a feel for how these things work if you've ever had trouble with these. Furthermore, if you've ever had trouble with stoichiometry, please take a look at the revision questions and the question set that will be further below, and go and just spend an hour or so working through them until these ideas are drilled into your head, because it's super important that you're able to do these calculations immediately and automatically, so that you don't have to waste time thinking about these calculations and using up space that could be used for actually thinking about the complex theory that we'll be encountering in the future. So stoichiometry, as we've discussed, is basically looking at this relationship between the amount of reagents that you have in your reaction. The only two things I'd like to cover really are this. One, think of it, if you are still having trouble with stoichiometry, think of it as tables and chairs. So what does this mean? So let's have a look at this. Imagine I have one table here. All right, so I've gone to IKEA and I've bought a table, and the table over here comes with 4 chairs. So I'm not an extremely good artist, but let's say we've got the 4 chairs here, all right? And together, this table and 4 chairs, they come together and form a dining set. So I'll write this as DS, I'll write this chair here as C, and this table here as T. Perfect. So the idea here is what we can do here is we can make a reaction or an equation. And what do I mean by this? Let's say, for example, we can say one table here plus 4 chairs forms one dining set, okay? And in this situation, this is similar to a chemical reaction. So one table here reacts with 4 chairs, forms one dining set. So this means now, with this ratio, I can kind of think to myself, if I had a certain number of tables or a certain number of chairs, or I wanted to create a certain number of dining sets, how many of the other things would I need? So I could start thinking along the lines of this. Let's say I wanted 3 dining sets, okay? So if I wanted 3 dining sets, I'd think to myself, in order to create one dining set, I would need how many? 4 chairs and 1 table, right? So one dining set would require 4 chairs and 1 table. So if I needed 3 dining sets, how many chairs and how many tables would I need? Well, obviously the answer would be something like 3 times 4 for this one, because we know one dining set creates 4, needs 4 seats or chairs. Therefore, 3 dining sets would need 3 times 4 equals 12 chairs. And of course, you'd also need 3 tables in this situation here. Simple? Okay, that's all right. If we come back here though, let's think of it in a different way. Let's think of it something like this. Let's say I had 2 tables. I could ask myself, how many chairs would be required to make a bunch of dining sets or completely use up these 2 tables? Well, I'd start off my thinking like this. I've got 2 tables here, right? And I know that according to this equation, one table requires 4 seats, right? So therefore, if I have one table requires 4 seats or 4 chairs, then 2 tables would require what? 8 chairs. Simple? All right. What if I change my situation to something like this? So these are really strange tables and chairs. So here we've got 3 tables require 4 chairs to make 7 dining sets. It's a bit weird, but it's a bit weird, but let's say that this is the situation. Okay, it's really strange. In this kind of situation, right, I could ask myself the same question or a similar question. This time I have 2 tables at my disposal. How many chairs would I require, and how many dining sets could I make to fully utilize these 2 tables? Well, all of a sudden the situation becomes a little bit more difficult here, right? Because I say 2 tables, all right, but then it takes 3 tables to make 4 chairs, and how many tables would 2 chairs make? It's a bit weird, right? So we've got 2 ways of dealing with this. Okay, and these 2 ways are the same way that we deal with ratios, because if we have a look here, what we essentially have is a ratio. Let me draw it out for you using the different color. So let's say these are tables here, and I'll draw a line down the middle, and these are chairs here. Okay, so what this equation over here is saying is that 3 tables will react with 4 chairs. So if I have 3 tables, it will react with 4 chairs. My question here is 2 tables, how many chairs would this react with? Okay, and this is a question mark, sorry. How many chairs would this react with, right? So we have 2 methods of dealing with ratios, and these were examined in the first unit. And the 2 methods were this. One, we can use the unity method. So we find out how much does 1 give you, and 2, we could use the cross multiplying method. So I prefer to use unity method, but some people like to use cross multiplying. But let's think about it, right? So 3 tables, 4 chairs, we could cross multiply it here to make 3x. I'm just going to make this here x, right? So 3x equals 8, so x equals 8 on 3, right? So therefore, x is the number of chairs that would react with 2 tables. So the answer here would be 8 on 3 chairs would react with 2 tables. That's a little bit confusing, right? So let's look at it in a different way. All right, so I've reset the screen here, but I'd just like to explain to you the simpler way in which this is going to be the unity method. So I think the previous method was the cross multiply method. So let's say in this situation, I had 2 tables. The way to do the unity method is this. I want to find out basically how much is the unity ratio or the 1 ratio. And let's have a look at what I mean by this. Let's say I start off with 2 tables over here, and I know that it reacts according to this equation. 3 tables, 4 chairs form 7 dining sets. So the way to if I wanted to find out how many chairs or how many dining sets were created, would be my method of thinking. I would get 2 tables, and I would divide that by the coefficient of the number of tables in the equation. So in this situation, I would get 2 divided by 3. Okay, so 2 divided by 3 gives me what's going to be my unity, right? If something had a coefficient of 1, there would be 2/3 of them created. So in this situation here, now just multiply this 2/3 unity ratio by the number of the coefficient that I'm interested in. So what does this mean? 2/3, if I wanted to find out how many chairs were created, I would do 2/3 times 4, right? Which gives me what? The same answer that we got before, 8 on 3 chairs. If I wanted to find out the number of dining sets created, I would do 2/3 times 7, giving me 14 on 3. So it's a very simple method. The method is this, right? First of all, you divide the number of tables. You divide the number of stuff that you have, moles of stuff that you have. Divide that by the coefficient, right? And then you get a number, and then you multiply that number by the coefficient that you're interested in.